Greetings to all space enthusiasts. Today, we're going on an incredible journey deep into time to learn how our solar system was formed. It's a story that spans billions of years and is one of the most fascinating in the study of astronomy. It all started about 4.6 billion years ago. At that time, a huge cloud of gas and dust existed in one region of our galaxy, the Milky Way. This cloud is called the Solar Nebula. Under the influence of gravity, this giant gas and dust cloud began to shrink. At the center, where the gravitational pressure was greatest, a protostar, our future sun, began to form. When the core of the nebula reached a certain temperature, thermonuclear reactions began. The solar wind from the newborn luminary began to disperse the remaining gas and dust into the surrounding space, and then the sun became the full-fledged star, emitting the light and heat we know today. As the sun continued to heat up, there were remnants of gas and dust around it that began to coalesce into larger formations. This process is called accretion. Over time, these small particles formed planetesimals, the first embryos of planets. Over time, through mutual collisions and gravity, the planetesimals merged to form planets. The inner planets, Mercury, Venus, Earth, and Mars, were formed from heavy elements such as iron and silicon. They became rocky and dense because the solar wind drove the lighter gases and volatile elements farther from the sun. But the outer planets, Jupiter, Saturn, Uranus, and Neptune, formed from ice and gas that were farther from the sun, where temperatures were lower. These planets became giant gas and ice giants with massive atmospheres of hydrogen and helium. As the largest planet in our solar system, Jupiter played an important role in its formation. Its enormous gravity cleaned up the space around it, absorbing many planetesimals or ejecting them outside the solar system. This prevented the formation of another gas planet between Mars and Jupiter, and the remaining material formed the asteroid belt. Jupiter may also have influenced the inner planets. For example, its gravity could have affected the orbits of the planets and even slowed their formation. Without Jupiter, our solar system might look very different. Our planet, Earth, is located in what is known as the habitable zone, a region around the sun where the temperature allows water to exist in liquid form. It is the presence of water that made the Earth habitable. One of the most exciting theories for the formation of the Moon states that it arose after the Earth collided with a hypothetical Mars-sized planetary body called Theia. As a result of this colossal event, a huge amount of material was ejected into space, from which the Moon was eventually formed. Along with planets, there are many small bodies in the solar system: asteroids, comets, and dwarf planets. Asteroids are mostly found in the asteroid belt between Mars and Jupiter, and are remnants of matter from which planets would have formed if not for the influence of Jupiter. Comets, on the other hand, are much farther out, in the so-called Oort cloud. These icy bodies sometimes approach the sun, forming long tails as the ice and gases begin to vaporize under the sun's heat. Pluto was once considered the 9th planet in the solar system, but after the discovery of many other celestial bodies in the Kuiper belt, it was reclassified as a dwarf planet. The Kuiper belt is a region filled with icy bodies and asteroids that lies beyond the orbit of Neptune. Pluto remains one of the most interesting objects to study, especially after the New Horizons mission, which gave us the first detailed images of this distant planet. The solar system continues to evolve. Eventually, in about 5 billion years, the sun will use up its fuel and become a red giant. It will expand and swallow Mercury and possibly Venus. Earth will also be at risk, but it is not yet known for sure whether it will be absorbed or thrown into a more distant orbit. When the sun sheds its outer layers, it will become a white dwarf, a small but very dense star that will take billions of years to cool down. The planets that survive this catastrophe will continue their orbit around the new, dimmer sun. The history of the formation of the solar system is a fascinating process that continues to this day. We continue to learn about the origin and evolution of planets and small bodies, and each new spacecraft and mission.